The topic that we are going to discuss, it is the covalent radii. So what does mean by covalent radii? It's a new topic to you, or yeah, the new lesson to you. So we have the introduction. Basically, the atomic radii is related to the covalent radii. So covalent radii, as the name has been shown, covalent radii. Covalent radii is related to the radius of the molecules that have single covalent bond between them. So by definition, we have the covalent radii is one half, or we can say that one half of distance between the nuclei of same atoms of the same molecule that have single covalent bond in them. For example, if we have a molecule like A and B, they're going to form the bond. This is their central nucleus, and the distance of nucleus to its outermost shell, this distance is known as atomic radius. And if we are talking about the distance between the radii, like the distance between the nucleus of two bonded atoms having single bond between them, is as d. And when we take half of this, like covalent radius, covalent radii, it is equal to d by 2. When we take half of the distance between the nuclei of the two bonded atoms, this distance is known as covalent radii. This is the A and this is atom B. This distance is its atomic size A dash, or atomic radii, and this is the B dash. So we have to take the half of the distance between the two nuclei of the bonded atoms. So this is the formula to find the atomic radii. Next we have the example of covalent radii of the hydrogen molecule. Hydrogen exists in the form of H2. So there are two hydrogen atoms like this, hydrogen 1, and the second we have the hydrogen 2. It's hydrogen and it's hydrogen. This is their central nucleus, and the distance between them is basically d, and when we divide it into 2, then we will get the covalent radii of hydrogen molecule. So from central nucleus to this is the radii atomic radii of both the atoms to their valence shell. The distance between the nuclei and the valence shell is known as atomic radii, and we are going to take the half of the distance between the nucleus of the two bonded atoms having single bond. This is known as the covalent radii. Next we have the covalent radii of the halogen atoms. Halogens are from group 7a, and the halogens included fluorine, chlorine, bromine, and iodine. All these elements exist in diatomic form. Diatomic form mean they have two atoms like F2, Cl2, Br2, and I2. So let's discuss their atomic radii. The first one is halogen fluorine. Fluorine like F2. If we are talking about the fluorine, then by drawing its structure like this, F2 as this is their nuclei, and the distance between their nuclei we have 143 picometer, and we take half of this, we will get 72 picometer. Now this 72 picometer is their covalent radii. When we take the next example, after fluorine, we have the second element is chlorine. We draw about the chlorine. Next, we have like this. This is their nuclei, and the distance between their two nuclei is 199 picometer, and almost the half of their distance we get 100 picometer. So this 100 picometer is their covalent radii. After chlorine, we have the second element is bromine. So Br2 stands for bromine. Now the structure of bromine like this. This is their nuclei, and the distance between their two nuclei is almost 228 picometer, and the half of this we have almost 114 picometer. So this is the covalent radii of the bromine. And the last one we have iodine, I2, as it is having the more larger covalent radii because it is having more number of shells as compared to the fluorine, chlorine, bromine. So its atomic size or the distance between the two nuclei is 266 picometer. When we take half of this, we will get 133 picometer. So this is the covalent radii between the iodine atoms. So this is all about our today's lecture in which we have discussed about the covalent radii. So if you guys have any queries about this, you can ask me about that in the comment section and I will get back to you guys soon inshallah. For that time, have a good day and Allah Hafiz.